Let's continue to look at multiple integrals. And now let's take a look at changing the order of the limits of integration. So here's another question similar to the one we just did. Well, it's the same question almost. So that's evaluate x squared to 2x dy dx. So the same graph actually would be given. So this is now saying x equals root y, which is this graph here. So if you have x equals square root of y, then you get the top half or the right side of the root, and then the plus or minus. And then you have for the line, if you just solve this for x, you see you get x is 1/2 y, which is the lower limit here. And in this case, then you're saying dx dy. So your segment. Oh, then look at this. See 0 to 4, and that's what this limit is, 0 to 4. And so now your representative rectangle. Let's change that color. Is going this direction. Sorry, is going this direction. And you're adding those up from 0 to all like this all the way to 4. So what we have then, when you integrate this, it would be the same value, of course. You can check that. Just integrate with respect to x first, so you get 1/4 x to the 4th, and then 4yx, and then you substitute in and evaluate. And you'll get the same thing, 32/3. So Fubini's theorem works really with the general regions as well. Now let's look at another example where changing the limits is might be necessary. Maybe you can do it, but it basically simplifies the integration. So let's look at this. So check this out. So suppose you had the integral from 0 to 2, integral from 0 to x squared, and the integrand is y cosine x to the 5th dy dx. Okay. So for this one, oh wait, let's, I don't want to redo the video, so I'll just move this down. Okay, suppose you had this. This was the original one. So suppose you have 0 to 4 and root y to 2. Oh, the integrand is the same. Y cosine x to the 5th dx dy. So suppose that was the first thing that was given. Then let's graph that region. So if we graph that region, look like this in the xy plane. So we have x equals root y, or y is equal to x squared for x positive. And then we have x equals 2 to be the same. And then we have y equals 0 to to y equals 4. So those are all your limits. So then you have the parabola like that. Make that 1, 1. And then 1, 2. Graph's not going to work so well. we'll just redo that. So we'll just make it like this. So then at 2, you have this region. So this will make it look a little better. And so this is your region in question here. So right now, we're going this way. And what we may want to do is look at our integration. So if we want to integrate with this with respect to x, what we're looking at is your x to the 5th here. And that might make it more difficult to integrate. So you'd have to do like a reduction formula on that to figure it out. So what you can do instead is change the limits of integration. You can swap them. So if you swap them, you don't use these values. You have to go, or you should go, to the graph itself over here and figure out how to do your limits, which I wrote up accidentally. So now you're going this direction, like this, vertically. And you're integrating from, so now this is your y equals x squared, and we already know it goes from 0 to 2. So you go from your lowercase y equals 0 to y equals x squared. That's what I have. Y equals 0 to y equals x squared, and that's your dy. And your x is from 0 to 2. 0 to 2. Now when you integrate that, you integrate with respect to y first. So then you get, this is equal to the integral 0 to 2. And so then that's just going to be 1/2 y squared cosine x to the 5th. And we will evaluate that now from 0 to x squared. So by substituting in, we'll get x to the 4th, which maybe you can look ahead and look at see your chain rule that's going to happen. So equals the integral 0 to 2. And now we're going to substitute in. And you get 1/2 x to the 4th. And then it'll be minus 0. So then that's just 0. Cosine x to the 5th dx. Okay, so now you can do your u substitution. So now we can say let u equal x to the 5th. Then du is 5x to the 4th dx. So then du over 5 is then your x to the 4th dx. So then we substitute. So here's x to the 4th dx, x to the 4th dx, and then you'll still have to substitute in your 1/5. So then maybe it's, I forget how long it's been since you've done integration, but check all that out. I know we did some on other chapters, but so you get 1/10 0 to 2 cosine u du. Then you evaluate 1/10 and then sine x to the 5th 0 to 2. So it's just 1/10 sine of 32. Just leave it like that. And again, right now that's just evaluating functions or integrals, evaluating multiple integrals. It doesn't really mean a whole lot right now because we don't know what this function is saying. So now let's look at the question about area. We'll find the area between two curves. So check this out. Next example. So find the area bounded by y equals x minus 2, y equals negative x, and y equals square root of x. So the first thing you want to do, like always, is draw the region. So you have to, or I will even ask you almost every time, let's sketch or draw the region. So let's do that next. And I'll just make this smaller than just blow it up. It's just easier to graph that way. So you have root x. So root x is this. Then you have two lines. You have x minus 2, slope of 1. So you're down here, slope of 1. So it's going to look like this. And then we have negative x, negative slope. Looks like this. Okay. So let's blow that up so we can see it a little better. So this is your root x. This is your y. This is your x minus 2. And this is your negative x. So check this out. If you have, if you're going this direction, then you're going to end up with multiple regions. Right, so it stops right there, and you have basically two different regions. You have this region here, and then you have this region here. So you can't do that in one, so you have two separate. If you go horizontally, if you went this way, would you also have two different regions? And it looks like the answer is yes. So the only way you can do this one is to break it up into two separate regions. These two, or it would be basically split by the y equals x, or not y equals x, the x-axis, and you'd have this top portion or this bottom portion. So we might as well do it this direction. You might as well go this way. So we have to break this up into two separate regions and go this way. So here and here. So that's what we're going to have to do. Area then is equal to, we'll call it area 1 plus area 2. So this is my area 1, so here, and this will be my area 2. So the first one we say is a double integral from negative x to root x. And then we go, it's 0, and then you would solve that to get 1. It's 0 to 1. So this intersection right here would have to be 1, 1. Well, that graph's not right. This needs to be down to. This needs to be shifted down to here, which helps us give us a little more room. So let's fix that. I know I could fix it and go back and do it on the video, but these precious time. So that's really down at 2, and then we're still this, all the rationale was the same, was correct, I mean. Okay, so you're still breaking it up into 2 separate regions like that. Let's try this again. So you have these 2 separate regions. I'll just leave it like that. So you have this one here, and then you have this one here. It's those 2 separate ones. So this will be my A1, this one might be my A2. Now I can actually fit it in there, which is kind of better anyway. So there we go. Same rationale and everything would look the same, but this intersection then is 1, 1. And this intersection over here is going to be 4. 1, 2, 3, 4. And you can set them equal and solve if you needed to, just as usual. So your function height, your integrand is 1, so you just leave it. So then this is just dy dx, and then plus the double integral from x. The lower one then is your x minus 2 to the upper, which is your root x. Lower to upper, lower to upper. So that is as well root x. And now you're going from 1 to 4. It's the next part, which is 1 to 4. And again, that's dy dx. So when you evaluate, you just get y, and then you subtract the limits of integration. So that's going to be equal to the integral from 0 to 1, and that's just root x minus negative x, so plus x dx, and then plus 0 to 1. Same thing, root x minus x plus 2 dx. And you can evaluate that, see what you get. Pause the video if you want and figure it out. You get 13/3. So that's an example of area. Okay, let's do one more and do volume. And we'll post all of these. Should be the first 3 sections. So next example, find the volume